So now, after we have finished with physical quantities, now we are going to discuss on units and what and dimensions. Remember that we say that physics as an experimental science concerned with measurement, and say that the result of this measurement is represented in numbers and also what in units. So now we are going to talk about the units. Where the units is the magnitude of any what physical what quantities. So any physical quantities has to have a magnitude. There is something that defines that physical what quantity. Now, for example, I can say just 20, or I can just say just 30. But precisely, we do not know what this 20 or this 30 means. So, units is what gives or is what defines any number or any physical quantity. Because we say that a physical quantity is any number that is used to describe a physical phenomenon. So without units, this number is just a number, but it's not a physical quantity. So now, these units of measurements are defined and they are also adopted by conventions or by laws. Someone, ordinary man, someone cannot just go and say, I'm now going to create my own unit. This unit has to be defined, and it has to be recognized by the science society. That's why we say that it is defined and adopted by convention or by law. So someone cannot just create his own unit. But units such as Newton, all these units they are adopted and they have been described by laws. So someone cannot just go and create his own SI and say, I'm going to use this so unit. That unit that you created has to be recognized and has to be accepted and then adopted by the whole of science society. So now, the system of unit used by scientists and engineers around the world is the metric system. But in the year 1960, this metric system is known or is changed, is officially known as the SI unit. That is the International System of Unit. This S is the system, this is the International System of Unit. So then there are some quantities in physics that do not have units. Such quantities are described as unitless quantities. Meaning they are physical quantities that do not have units. No, they have no one without units. So these kind of quantities, they have the numerator and denominator of these quantities are equal. This means that they will cancel out one another. So they are like of trigonometric ratios, sine, cosine, tangent, strength, and also phi. These are units or these are quantities that are unitless, meaning they do not have SI units. Because the numerator and denominator will cancel out one another. Just like in tensile strength, we say that it's extension over length. If it is meter, then it's also a meter. They cancel out one another. So now, then we are talking about dimension. A dimension is the way of relating fundamental quantities of mass, length, and time. Using letters like mass, we use capital letter M, L, we use capital letter L, and T use capital letter letter T. So the way of relating these physical quantities, this unit of mass, length, and time is known as dimension. If we can find unitless quantities, then probably we will also have quantities that we call dimensionless quantities. So dimensionless quantities can also be known as via quantities, can also be known as what field quantities, can also be known as scalar quantities, or can also be known as what quantities of dimension 1. Now, for example, m here cancel out m equals 1. So remember that they are quantities with no what dimension. So what is the application of this dimension? Dimension has only 3 main applications in physics. The first one is to derive the unit of physical quantities. Number 2, to verify the correctness of physical equations. The thirdly is to derive exact relationship between measured physical quantities. These are the only 3 applications of dimensions. So now I am going back to discuss about the physical quantities, each physical quantity with its unit and also with its own dimension.